A. You've got sound there. Okay, that's fine. And now I'm gonna set up here to this here in, but I don't know where is it gonna AA. Okay. And you should have signal coming in there. Zoom 1. Auxiliary send zoom 1. AA. AA. USB. Okay. It's got a delay, but that's fine.
Yeah. Check, check. 1, 2, 1, 2. 1, 2. Check, 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 check. Hello, morning, morning. This is the sound check. Check 1, check 2. Checking the microphones. Thank you. Yeah. Nice.
Yeah.董教授，你好。董院士，您能听到我说话吗？董院士。哎，您好，您好。啊，好，谢谢，谢谢。我们稍微测试一下哈。
效果。对，镜头稍微。
稍微等一下哈，我出去听一下。
嗯。
董院士您好。
你好，你好，主持。
好的，好的，没问题。现场可以听到您的声音，您能看到现场画面吗？
看不到画面，是这个，应该是这个 slide 吧，应该是背景 background。
哦，对，您能看到 slides，但是看不到现场画面，对吧？
看不到现场画面。
哦，好，稍等，我让他们调整一下。
嗯。最后现在可以看到现场画面，
哦，好的，好的，好的。
嗯。
好的，好的，稍等哈。Yeah, I think everything is okay.
Okay, so you removed the moderator.
Oh, 1 second. Sorry, Doctor.
Andre, this gonna work on the next screen, yeah? On the map. On what? The next screen. The other. Same model, yeah? I don't know. I've never used Gonna try.
Okay.
Yeah, we good.
It's all good.
So can the gentleman stay online?
Stay online?
Yeah. Keep online, keep himself muted until he listens, he hears his name.
Okay.
We'll keep broadcasting all the audio for him, so he can see everything that's being broadcasted on the Zoom call.
Okay. 好。
好的，行。
哦，行，董教。
就这样 ，OK，that's it。
行，董院士，那麻烦您可以就是一直在线上，然后大概到您的时候，可以吗？
我这个到10点钟了吧，应该是。
不好意思，刚才没听到。
我的峰会时间不是10点吗？早上10点开始了。
对。
行。我把视频关了吧。对，好。
好。
I'll keep the meeting. You can leave the meeting. You can rejoin the meeting. But I will keep the meeting live. Okay. Let him know.
好的，董院士，您可以就是稍微晚一点，因为您那个 panel 是大概11点开始，您可以就是 panel 开始之前提前10分钟上线，如果您有其他的事情的话，就是可以不用一直在线上。I think I can't hear him.
Oh, sorry.
Can you hear me now？
不好意思，刚才 mute 了。您再说可以吗？
我先问一下，我时间是10点，我上面10点半还是11点呀？
您那个 panel 是正式预计是11点10分开始，您可以比如说10点半左右上线。
OK， 好的。
好的，谢谢您，谢谢。行，您可以就是中间 leave the meeting， 然后稍后还是同样的链接进来就行。
OK， 我可以 leave meeting 是吧？也行，好的。
He can leave the meeting.
Sorry.
He can leave the meeting.
Yeah. You can rejoin.
Yeah, you can leave the meeting and rejoin.
All right. OK, thank you. OK, see you later.
Thank you. See you later.
Bye.
I'll keep.
Should I? Can I try it? Here we are on a summit that's full of intelligent ideas and thoughts. And now, 可 The summit will begin at 9:10. Good morning, ladies and gentlemen. Welcome to 2022 China-UK Technology Summit. To provide a great experience in the summit, we would like to announce the order of the venue. Please put your mobile phones on silent or vibrate mode during the summit. Please do not walk around during the summit. If you have any questions about the summit, please ask our staff members for help. Thank you so much for your support and cooperations. Please take your seat. The agenda of the summit is on the screen. The summit is about to begin. Good morning, ladies and gentlemen. Welcome to 2022 China-UK Technology Summit. We are so honored to have so many distinguished scholars, experts, and entrepreneurs here. I'm your host, Serena Liu. This summit is held by Imperial College London Chinese Students and Scholars Association, collaborated with Oxford CISA, UCL CISA, LSE CISA, and supported by more than 100 institutions, CISA, venture capital organizations, incubators, media, etc., from China, UK, USA, Canada, and European countries. And we also have industrial elites, experts, scholars, young leaders, entrepreneurs, startups, and eco-partners in various fields joining us today. This is no doubt an annual feast that's full of high-tech achievements and emerging technologies. And we are so happy and excited about what will be presented to all of you today. On behalf of the organizing committee of the 2022 China-UK Technology Summit, I would like to express our most heartfelt thanks and warmest welcome to all of the guests and peers from all over the world who are joining us today, here at the venue and across the globe on the internet. The theme of this year's summit is Advanced Technologies for Smart Cities and Sustainable Development. With this common dream and expectations, today is a starting point for us to move forward together. It's my honor to announce that the 2022 China-UK Technology Summit is now begin. Let's move into our opening ceremony section. First of all, let's give a round of applause to the first opening guest, the Minister Counselor of the Chinese Embassy, Ms. Zhang Jin, to give a welcome speech.
Distinguished guests, distinguished professors, all the students, dear students and scholars from China and UK and around the globe, good morning and good afternoon. I'm delighted to join you at the opening ceremony of the 2022 China-UK Technology Summit, as well as the Young Scholars Forum. First of all, please allow me to extend my sincere thanks to the Chinese Students and Scholars Association of the Imperial College for inviting me and my colleague to this event and organizing this sharing platform for young researchers for both countries. Science and technology, as we all know, is a powerful drive for economic and social development in our era. Sustainable development has been one of the UN priorities for decades, and in recent years we have seen the trend of integrating sustainable development and smart cities together by using the latest technologies such as green and low-carbon energy, data sharing, and end-age cloud net intelligence. In this process, we have been increasingly aware that without joint efforts of all the countries, goals such as global climate change or sustainable development or smart city will be too difficult, if not entirely impossible, to reach. Countries developing and developed, Eastern and Western, need to work together for our common goals. China and the UK have established a partnership in education, research, and science in the past few decades, and we have witnessed many remarkable outcomes. For example, according to a report released by a team led by Lord John Johnson, 20% of UK's high-impact research has collaboration or engagement with China, and the number of academic dissertations and papers published jointly by researchers from China and UK has increased from 750 in the year 2000 to over 1,600 in 2019, bringing benefits for both sides. Young researchers, as we all know, are full of innovation, creativity, and vitality, creating platforms and opportunities for them so that they can share information, exchange ideas, and explore the unknown world with the peers from the rest of the world is what we as educators need and should do now. Only if our young generations, including future scientists, researchers, professors, business leaders, developed their capacity of working together with people from different backgrounds, can we have the hope to solve the common challenges of human beings and realize the UN Sustainable Development Goals in the future. I hope and I believe that today's summit and forum will provide a valuable chance for the young researchers from China and UK and other countries to discuss the topics of common interests, share their insights, and enlighten each other. I wish every success for this event and wish all of you an enjoyable and fruitful experience. Thank you.
Thank you, Minister Counselor, for your amazing speech. Please welcome our next guest speaker, the Fellow of the Royal Academy of Engineering, Head of the Department of Civil and Environmental Engineering, and Principal Professor of Positioning and Navigation System at Imperial College London, Professor Washington Yodo Oching. Welcome.
Thank you very much for that very kind introduction. I've just walked in, so it's very well synchronized. It's very cold outside, and Lilin Tong, who just welcomed me outside there, he's from Harbin, and he was outside there in a T-shirt, which is quite interesting. So thank you very much, ladies and gentlemen. My wife and I are delighted to be here to partake with you. But on behalf of our Imperial College London community, my wife and I would like to start by expressing our very deep gratitude and thanks to the organizing committee of the UK-China Technology Summit for inviting us to partake with you on this very important day. So I lead Imperial's Department of Civil and Environmental Engineering, and I also am part of the management of Imperial's Institute for Security Science and Technology, ISST, and also Imperial's Space Laboratory. So I've got an interest in civil engineering, in security and resilience, as well as space. So it is wonderful to see so many young people here in person, particularly after the very long fight still ongoing in some areas against the COVID-19 pandemic. I'm also very aware that there are many joining us online. So whether you're here in person or joining online, thank you very much for attending. As I always say, you are our future, and to some extent, my generation and after that have, to some extent, failed you, and so we are hoping very much that you can take on the mantle and help us address some of the challenges that we're facing, some of which are existential threats. So it's great that you're gathered here at the RGS for the 2022 UK-China Technology Summit to address some of those world's challenges. Now, talking about challenges, as I've said, some of which are existential, I see them through a pentagonal vectors diagram, which is on the sides of which are natural bio threats, such as COVID, social, environmental, physical, and cyber threats. But they can also be looked at purely from the three pillars of life, as I call them, which are social, economic, and environmental. Then there is the detailed question of the corresponding threat landscape, some of which are captured in the very well-known United Nations Sustainable Development Goals, the SDGs. So clearly, technology, which is the theme of this summit, has a huge role to play in addressing those challenges, and it is wonderful for me that two of the greatest innovation countries, the United Kingdom and China, can work together through collaborations enabled and facilitated by this kind of summit and others. I'd also like to add that I'm delighted that Imperial College London is playing its rightful role, working with some of you and the organizations to be at the forefront of technological innovation. So, my wife and I extend our thanks once again for inviting us, and we wish you a most productive summit. So thank you very much. 谢谢.
Thank you, Professor, for the speech. Now I would love to introduce Lord Waverley to the stage, the Vice Chair of the All-Party Parliamentary China Group. However, Lord Waverley is not able to present today for some reason, but here I have the words that Lord Waverley would love to share with you all, and please allow me to share these words with you for him. Good morning, ladies and gentlemen. I'm delighted to join you at the 2022 China-UK Technology Summit. For the past 2 years, the effects of the pandemic have continued to have detrimental effect on the world economy, imposing severe damage to the development. Under such circumstances, this technology summit is timely and bears significance for future international collaboration, especially in the field of smart cities and infrastructure, sustainability, and tech-driven entrepreneurship. The UK and China are both world centers for technological innovation. Since 2012, it is calculated that the UK has 5.5 million small businesses, with 64% of the labor force wanting to start a business, with the average age of those entrepreneurs being 40 years old. A large portion of these companies is innovation-driven, driving sustainable development. In China, rapid growth in entrepreneurship with innovation initiatives is supported by the government, especially those in high-tech industries. I know there are 168 high-tech industrial development zones situated in the major cities, fueling long-term economic development. According to the Invest in UK tracker by Grant Thornton, a total of over 860 Chinese invested companies now operated in the UK, generating £63 billion in annual revenue and providing over 61,000 jobs. By last November, two-way FDI stock reached $47.4 billion, an increase of nearly $5 billion compared with the level before the outbreak of the COVID. I am proud that the UK, therefore, is identified as a world leader in green finance and low-carbon technology, with our universities providing the environment to inspire students to challenge themselves and to create opportunity to fulfill entrepreneurial dreams. With all the challenges that exist on the world stage, it is for sustainable trade reflecting today's environment that be a catalyst for cooperation, particularly when identified with the commitment to green development and protection of the environment. In expressing appreciation to the organizing committee of the summit, my best wishes and success are to all scholars, students, professionals, and entrepreneurs. The future is with you. Thank you, Lord Waverly. Even though you can't be here, but your words are still very inspiring. Now, our next speaker also has some insights to share. Our next speaker is Professor Ma Daqing. Professor Ma is the member of Academy of European, VOC Chair and Mackintosh Professor of Royal College of Anesthetists. Unfortunately, Professor Ma cannot make it to today's presentation, but he has a video for us to share his insights. Let's hear the words from Professor Ma in his video.
Dear distinguished guests, dear friends and colleagues, thanks for inviting me to attend 2022 China-UK Technology Summit. I'm sorry I cannot be with you in person. Therefore, let me share my personal views through a video recording. The summit is held in the right time and right place. Why I say so is because the bilateral relations between China and the UK meet some difficulties. Therefore, it's needed we, our scholars, to give help on people-to-people dialogue for rebuilding mutual benefits between two countries. Imperial College London is good at science and technology. The summit held in Imperial College will generate some impact. I noticed that there are some hot topics in these summits today. For example, biotech and medtech. I do not have much knowledge about biotech, so I leave to other experts or scholars to comment on. I only comment on medtech. Telemedicine can help to improve access to Medicare in rural areas, can reduce traveling time and the cost. Most importantly, it provides great convenience to old people, to old patients, and to disabled patients. Human is the most complicated animal. Culture, diet, lifestyle are so different. And all those make each our individual is so unique. Therefore, personal medicine can help to improve effectiveness of Medicare and treatments. It is ultimate goal for medical practice. Wearable biomedical sensors, for example, freestyle lateral blood glucose sensor can provide huge convenience and real-time data for more precise health monitoring. The great potential and cost-saving measures in these areas I mentioned above, of course, not only limited in those areas, have not been recognized by governments, medical authorities, and medical community. I hope the summit held today will generate some impact for wide clinical applications. I wish 2022 China-UK Technology Summit a great success. I hope to see many of you in person very soon. Otherwise, I wish you a Merry Christmas. Thank you.
the amazing speech. Now it's time to welcome our next guest speaker, Mr. Andrew Wolstenholme. Mr. Andrew Wolstenholme is the Order of the British Empire for services to the construction industry, Fellow of the Royal Academy of Engineering, Fellow of the Institution of Civil Engineers, Construction Director of the Heathrow Express, Director of Innovation and Strategic Capability of Balfour Beauty Group, CEO of Crossrail, Group Director of Lane O'Rourke, and Chairman of Health Partners Limited. Enough of introduction, let's give Mr. Andrew Wolstenholme a very warm welcome.
Well, thank you very much indeed for that introduction. It probably makes me pretty old if I've done quite a lot of those things. Can I just thank the organisers for this and for the invitation to come here today. What a fantastic opportunity for people who represent all walks and all disciplines of the scientific, the engineering life to come together and to share their ideas on this hugely, hugely important subject. Also to come here into this room where for many decades and even centuries, scientists from across the world have brought their discoveries and their innovations, and they've shared them in the pursuit of pushing boundaries for the benefit of humanity. So really a great place and a great choice to be. Let me just start by saying what a hugely important topic this is that you've chosen: sustainability and smart cities. And I know later I'm going to be on a round table and ask questions for which no one in this room has the precise answers, but the idea to come together and to discuss them and to understand where the boundaries and where the limits are is really hugely important. Our cities is where most of the population in the future will live. It's where we will work, it is where we will relax, and it is where your families will live. But with more people in the world and with fewer and limited resources, how will our cities respond to the challenges and to the opportunities in the future? A city that is smart and sustainable will balance the needs of those people who live there with the resources that are available. And the question is that going to be a constraint to us, or is that going to be an opportunity? Will we find a way to share the resources, to share the capacity, to share the resilience, and to share the redundancies that today we build in order to make sure that the cities, some of which have developed over many centuries, can accommodate the needs of our future society? Will smart cities be the place where you choose to live? And if so, why? What defines a smart city? And my question to everyone here in the room and at this university and in all the universities working together and everyone online today is, what role will you play? What difference will you make in this huge existential challenge that we have here today and we have to deliver? I'm a civil engineer. I have had the privilege of leading a number of UK's, London, and international programs, and I feel hugely honoured to have had the opportunity to do that. This has enabled me to understand why we build the social infrastructure, the schools, the hospitals, and the public spaces, why we build the economic infrastructure, our schools, our roads, our rail, and our airports, and how it is that they come to provide the utility and the service that we need. Yesterday, I was at a site called Beckton. It's in East London. It is a sewage works. It collects together London's waste, about 60% of London's waste, and it turns it into water that goes into the Thames and in future water that you can drink. And for years and years, in fact, our original sewer system was built in the middle of the 19th century by someone called Basil Dress. And today we're upgrading that system with a massive program of tunnels and sewer works called Thames Tideway. But the question we had in that sewage works was not how could we increase the capacity and improve the process of something that we all take for granted and we don't think about too much. The question was, how can that provide more than one function? How can that sewer system become a net giver of energy back into the system, back into the grid, back into the ecosystem of London? And there is a real opportunity now for these systems to do more than one thing. And that requires us to think differently. It requires us to think out of the box. It requires us to bring many, many different people, from planners, from policymakers, from engineers, from technologists, and scientists at the same time. So as programme of Terminal 5 out at Heathrow, a terminal facility to bring 30 million passengers from around the world and to travel on to their final destination or here in London. As the Director of Construction of Heathrow Express and recently as the CEO of Crossrail, I asked myself the question, are these smart systems? Do they provide a seamless, reliable, safe journey from where people want to live? And the theory of Crossrail was to bring 2 million people to within 45 minutes of central London. That's smart, to enable people to live outside of London, but also to be able to come into London. And in order to do that across the legacy systems of London, across some railways that were built 100 years ago, some that were built in the last 2 or 3 decades across, we have to get people in this room to understand and to explore the complexity of providing a modern, smart wrap to an existing infrastructure system, to cross the operational boundaries, the council's boundaries, the population's boundaries, to cross the technology boundaries, the railway operating system boundaries, and at the end of the day to be able to put in one single train a signalling system that crosses 4 different signalling interfaces and boundaries. And that was the complexity. And I actually think, in fact, I have a request. Go on the Elizabeth line over the next couple of weeks and go from one end to the other and have a look at the way in which I think this brings together on a seamless ticketing system. You know, we used to have paper tickets. We now have these on our smartphones. On a single information system. In, I think, a system that you'd be pleased and you'd enjoy. In a system that brings art and brings culture into one single transport system. And I think actually it goes quite a long way to understanding how you can turn parts of ancient cities into modern-day smart systems. What have I left, not just in building physical assets and digital assets, but I'm very proud of 2 things that the teams I work with have been able to do. I came here probably 10 years ago when I built Terminal 5, and I met up with some Imperial College students and one of the professors called David Gann. David Gann was the professor here of entrepreneurialism and innovation. And we sat in a laboratory nearby just to talk about what it would take to put an innovation program in place. And as a result of that on Terminal 5, we had posters on the walls with our teams with light bulbs on. You know, we were all contributing to the ideas as to how you push the boundaries on Terminal 5. And we had an innovation program that gained mass and gained credibility. And David helped me bring that program into Crossrail. And again, we had a limited amount of money that we invested. That was match funded by industry and match funded by government. And so you could create the circumstances where actually ideas to push boundaries had funding and got that critical mass. And that program that we called Innovateen on Crossrail is now a national program called I3P. It's where the industry and the consultants and the contractors and the owners and the operators of infrastructure come together and pool the resource in order to make sure that there is an acceleration of idea and of development across the industry. And the second thing, I guess, is not, again, the physical or the digital infrastructure, is when I was the leader of the Construction Leadership Council in trying to form for this sector, what are the common ideas and the common ways of working that is going to accelerate change across our sector and across our industries? If you go to aerospace in this country, then it's wings and it's engines. That's what we do well in this organization. And automotive is about driverless and battery technology. And for the sector that I was representing, it was about the digitalization of the front end, the creation of better, more certain outcomes by getting your digital twin designed and developed right at the early phases. It was about breakthrough technologies in manufacturing to improve the productivity of how we build our built environments and the decarbonisation of the built environments. And it was about the ability to land smart assets so that they were able, over their life, their 50, their 100, their 150-year life, to understand how they adapted to the environment and how they're able to use the energy and the carbon much more efficiently. And I think it's really understanding the building blocks, not of physically of what we do, but of how we do it. And I think if industries can learn the digitalization, the manufacturing, and the through life through smart, this is the foundation of smart cities. This is the foundation of us all pushing the boundaries for the benefits of humanity. I too arrived only just before, and I was at Clapham Junction, which is a railway station just outside London, and we had to wait 10 minutes because the points had frozen. The railway infrastructure had got cold overnight, -6, -7 degrees centigrade, and had frozen. And I asked myself, are we going to develop smart cities that accommodate global warming, or are we going to build smart cities that avoid global warming in the first place? Thank you.
Thank you for the amazing speech. Our next guest speaker, Professor Xu Hongming, is Professor of Energy and Automotive Engineering at the University of Birmingham, Director of the Birmingham Center for Advanced Vehicle Research and Education, and Visiting Professor at the School of Vehicle and Transport at Tsinghua University. For some reason, Professor Xu is unable to attend today's event, so we will hear the words that he wants to share in the video that he sent.
Thank you, Chairman, for the introduction. Hi, everyone. Good morning. I'm Hongming Xu. I'm delighted to have this opportunity to share with you on my talk. And the title of my talk is Sustainable Green Transport Systems. So I'm from University of Birmingham, where I work as director of the Case Vehicle Research and Education Center. In this very short presentation, I will start with some information for the background of the research for the case studies and some activities ongoing at Birmingham and the international community, and finally, a brief summary and outlook. Here is an overview look of my campus at Birmingham University. And at the left-hand side, you can see the year I graduated from Imperial College with my PhD in 1995. And finally, when I was leaving Imperial College, I was the chairman of the CSSA Imperial College and also the vice chair of the UK CSSA. When I was celebrating the 50 years anniversary of China. And so that is my brief road coming to the vehicle. Here we're talking about the roadmap. So you can see the topic we are very interested in is the energy transition time now we are facing for the lower or the actual lower carbon vehicle in the future. So at the beginning of the century, we start to the transition from the conventional combustion engine to hybrid, gradually from mild hybrid to full hybrid and plug-in hybrid. We have seen the rapid development of electrical cars, and we are looking to the future application of a hydrogen for fuel cell type of clean zero carbon vehicle energy use. So all countries around the world are working on this roadmap. Some countries are faster on the electric car development. However, the outlook is, in general, moving towards this roadmap for energy transition. By the prediction of the International Energy Agency, we will see in the next 10 or 20 years, we will see the electric cars will penetrate to more than 50% of the market. The application of these electric cars, including plug-in hybrid, battery electric cars, and fuel cells electric cars. Only these three is considered true electrical vehicles. However, the new type of fuels, or zero carbon or low carbon fuels, will determine whether internal combustion engine will continue to be used on vehicles application. Technology we are developing for future sustainable transport system can be summarized by these four letters, CASE, briefly CASE. So what is a CASE? That is connected, autonomous, shared, and electric cars. So the connection, automation, sharing, and electrification. That's the four areas now we are all working on for future technology. Our University of Birmingham has a cross-campus research center and focus on these areas and for autonomy, sensing, business, strategy, impact on the environment, and sustainability. And this center is also developing joint degrees for education to train the future engineers to prepare for the transition to the new technology of vehicles. And the structures or the framework for the CASE vehicle technologies is arranged as such. The conventional engine development facility still is at the center of the powertrain for next several decades to continue to improve the efficiency. Of course, it relies on the development of new fuels, or we call now e-fuels, have a lower or zero carbon content so that the emissions of the vehicles will completely eliminated. And the Euro 7 standards legislation has been just published, 2035, will be largely relying on electric cars in the UK and Europe. And the work structure here, we will use the combination of electrical devices like battery, motors, to be combined with the combustion engine for the time. And the powertrain technology still remains at the center of the research. However, all this transport system using either new fuels or electric power will be connected to the outside of the world to focus on application for the true transport scenarios. The research will be carried out now mostly using virtual environments. In other words, it's going to be work on a desktop computers using software and digitalization technology to research on the simulation-based work combined with reduced work on experiments. So this diagram shows how this data will be transferred from the network of the computer science and also finally on the sky, from the sky or the cloud to be combined onto the platform of this vehicle platform called the V2X network. The drive all the enabling technology is going to be associated with the development in all areas of engineering and science. And here this diagram shows that optimization is the objectives, and the cost and the speed remains the priority for industry. In the next 10 or 20 years, the cost of the production development will need to be reduced dramatically to 1/3 of the time we are experiencing now. And so this need revolution of the techniques in the product development. How will be done? It will be, of course, the hardware development is still one of the key areas, and the big data technology, or we call it digitalization, will be the enablers and to allow us use the tools developed different from today's software application. And that software is largely centered on artificial intelligence. So artificial intelligence will be used finally in all areas of the development products, including vehicle and the transport system and also the management. So this will be merging the cyber and the physical system in the end to make the optimization in the design stage and also in the application stage when the vehicle is on the road, and including the transport system, including the pedestrian as a whole system, to make the city and make the whole community of the society much more efficient in operation. And one of the very important concepts is called digital twin in the digitalization technology development. What is a digital twin? Digital twin, in a simple word, is a model, but it is different from the model we are used to know. A model can simulate a product or a piece of hardware, can be considered as a very preliminary stage of the digital twin. However, when the object becomes so complicated, like a vehicle, a simple model cannot be considered as a digital twin, will not have the function of the digital twin because the object in operation, in application, will change with the environment. It will have a life. So any model which can simulate the life of the object or the product can be considered a digital twin. It will include the hardware itself and the software itself, and in the end, to make a cycle repeatable and the life evolution can be reviewed by the software. That is what we call digital twin. So in one simple word, a digital twin is a model with life. So in order to make the international collaboration, and here we're talking about our association with China. Here we have millions of engineers working in the field of automotive engineering across the world. So recently we have formed a global alliance of overseas Chinese Society of Automotive Engineers, where I have been elected as the first chairman of this global alliance. And we have organized 2 international or global connection of all the overseas Chinese Society of Engineers online mainly. And this organization has been recognized by International Federation of Automotive Engineers, FISTA, as a formal strategic partnership organization. So we will work with FISTA to use the platform to enhance and promote the communication between all automotive engineers, including those overseas Chinese, with the rest of the world. So hopefully this will be good for promoting the collaboration between UK as well to China in the field of automotive. And that is all I talk for today about sustainable transport system, but I would like to use this opportunity to congratulate this China-UK summit. I would like to thank the organization for giving me this opportunity to talk to you. Thank you very much indeed. Thank you.
Thank you, Professor Xu, for all of this information, knowledge, and amazing insight. Now it's time to welcome our next guest speaker, Dr. Jeremy Woods, the Associate Professor of Sustainability and Director of the Imperial College Center for Environmental Policy. Let's give him a round of applause.
Oops. Thank you very much, and what a pleasure it is to be here, and an honor it is to be here and to look out onto this audience in this very venerable organization, the Royal Geographic Society, with a long history. So I'm Jem Woods. I'm the director of the Centre for Environmental Policy at Imperial College London, and as I was listening to the fantastic introductory talks, I was thinking about my history of interaction with China and Chinese science. So I first started visiting, I've been visiting China all of my adult life, and I've been fascinated with Chinese development and Chinese activities, and have been lucky enough to have seen that. I've seen what to me are extraordinary changes. China in that time, since the early 1990s through to now, has undergone such an extraordinary developmental change. It really has seen quite massive and pervasive changes in society. And personally, I've learned an awful lot from watching that. I started my interactions in China in collaboration with the United Nations Food and Agriculture Organization. And I visited China on multiple occasions in the 1990s through that activity, and I went up to Shenyang, right across China, looking at agricultural potentials and looking in particular at demographic transitions that affected sustainable agriculture and food security provision in China. I then moved on to work with the China-UK Sustainable Agricultural Innovation Network, that really focused around what is it that China and Chinese science can do, what innovations can be delivered to deliver sustainable agricultural solutions into China. And then finally, and well, hopefully not finally, but more recently, we've been working on tools to combat climate change in collaboration with Chinese science, but at a global level. So tools that allow us to look at technological innovations right across the human system. What can we actually do to meet these incredible systemic and, as everyone has said, existential challenges that face not just Chinese or UK societies, that face us globally? And I want us to be in no doubt that these challenges are severe. So as we see with the emergent and clarity in that emergent understanding on climate change, just how serious the climate change challenge is to human existence. So climate change will and already is affecting the fundamentals of the provisions of those fundamental materials to human development, particularly in the food system. So we see flooding, but often in many areas, and in particular right across China, we see alternating flooding and droughts. We see peak temperatures This year, I was driving in my car on my way home, and I saw the temperature gauge in my car go above 40 degrees centigrade for the first time probably in UK's history. But that's fundamental. Temperature is a fundamental perspective on what drives crop growth. Above certain temperatures, crops will terminate, and we won't see food production. Equally, water availability, or too much water, is a really substantial problem in terms of crop growth. And so we need to be thinking about all of these problems together. And now we're here on the start of the second week of the Biodiversity Conference of Parties, so the equivalent to the Conference of Parties on climate change, but the Conference of Parties on biodiversity. And in that conference, it has become starkly clear that we are on the verge of the global 6th species extinction event. Now, it's less obvious to many people how important biodiversity is as an underpinning service to humanity. But it's becoming much clearer now that we cannot continue in the ways that we have been. And so when I think about sustainable development, I think about these emergent existential challenges, the timing of those challenges, but also the importance of our human capabilities to address those challenges and to meet not only our aspirations, but the aspirations of our children, your aspirations and your children's aspirations as you go forward. What does it mean to live in a modern world? How can we affect and move that modern world forward? And it's so wonderful to see all of you here thinking about these problems and preparing yourself to think about these problems. So I've talked about the environmental challenges that underpin the crisis that we're looking at, that's often stated as the climate crisis, but is much more broad than that. And it's really a developmental crisis. And then we have to think about the energy system. So I started with that work under the Food and Agriculture Organization, working on food systems, but the linked challenges of food and energy systems, particularly with bioenergy. And so in the energy system, much of the climate challenge is characterized by our use of fossil fuels and the emissions associated with fossil fuels. But we now understand that 30% around a third of global greenhouse gas emissions are associated with the food system. So again, we need to think again about how we interlink, how we perceive these big problems. What knowledge do we need and what knowledge do we have on these big systems? How do we connect these systems together? No longer allowing ourselves to think in silos, but allowing ourselves to connect things together. And Andrew, your point about the need for smart systems that are able to join things together to improve our knowledge is, in my view, is absolutely correct. And that's what's so interesting about what all of the other talks said to us. So when it comes to human development, how do we perceive ourselves and how do we think about ourselves in the future? We need to deliver not just the technological changes, but also the social changes. We need to deliver the tools that unlock the social changes that are required for us to meet these future challenges. In our work with supporting in a large team of European scientists, we helped to develop something called the European Calculator. And that was designed to understand what interventions are possible and likely and needed in order to deliver a net zero pathway for Europe underneath its Green Deal. We looked at those problems and we looked at those tools and we looked at the pace of change that's required. But in that tool and using those tools and using that emergent understanding, we came to understand that technological change itself will probably deliver about 50%, about half of the solution space. Behavioral change, the way we think about and use the resources that underpin our development and our aspirations, behavioral change will be needed in order to meet the other 50% of the changes to deliver that net zero future. The other thing that was really important as an outcome from that tool was that no matter how hard we tried to find pathways into the future for the European Union as a whole that delivered net zero, about 50% of the emissions were leaked outside the European Union. And increasingly, I'm afraid, no matter what we think about future directions, and there's a very strong push for localism, a political push for localism, we are in an increasingly and continually increasingly connected global world. And that means the markets, the systems, the cultures, and everything that we think about, we will need to find solutions that encompass the globalization of the world. And so as I get to the end, and I'm sure you'll be pleased to hear that I'm getting to the end of my talk, the new emergent concept of planetary health that links human health with environmental health is central to the way we think about the tools that we need, the knowledge that we need to address these existential problems and to deliver that future, the future that we and we hope that our children will want. And so I've talked a lot about these kind of global level pictures, but what might that mean for you and for us in that room? Well, I'm guided by a sentence, by a phrase from Mahatma Gandhi. The world has enough for everyone's need, but not enough for everyone's greed. And as the population grows, we need to understand what that really means and how we can increase the enough part for everyone's need through efficiency gains, through better understanding of how systems come together, through increased productivity, etc., etc. But we also need to understand that other part about greed. How do we deliver the aspirations of the future? How do we deliver politically and societally acceptable outcomes in the future that meet those aspirations without pushing us over planetary boundaries? And so, for me, and I hope for you, sat here in the Royal Geographic Society with its long history, its long spatial understanding of history, next to Imperial College London, the Science Museum, the Natural History Museum, and the Victoria and Albert Museum. How do we think about bringing these societal challenges together? What is your role in understanding that future? And I think there we've talked about things like the interaction with AI, the new ways of improving it. But critically to that is that we have a common view on generating the new knowledge, the new technologies that will help us enable that future. And so that's my challenge to you. And in fact, the new president for Imperial College, Hugh Brady, came to visit my department a couple of months ago. And when he came to visit our department, he wasn't really that interested in what we had to say to him as the staff and the academics. He came back and he said, what I really liked was meeting your students. And when I met your students, the first thing they did was tell me off and tell your staff off. They told us off because we, the elderly people in the institution, are too pessimistic about the future. There are so many tools, there's so much innovation ahead of us that we need to understand, and us elderly people need to stop being so pessimistic and provide you with the move ahead, provide you with the tools to guide you, not with a naive sense of outcome, to be clear about the challenges ahead, but to provide you with that enabling optimism to be able to go forward and confidently meet the challenges of the future. So thank you very much for having me here. It's been a real pleasure, and it will be a real pleasure to be on the panel. Thank you.
Thank you, Dr. Woods, for this amazing speech. We just want to say a huge thank you to all the guest speakers for sharing these enthusiastic words and bringing in just inspiring insights. These words inspire us to not only focus on technology innovation, but also to understand the direction of the industry, to broaden our horizons, and to work together with an open mind. With what we learned today, I believe we now have more confidence to reach the peak of the field, step by step. Thank you all. Now we'll have half an hour break for refreshments, and we have set up an innovative design exhibition from the world's leading artist teams, which will be guided by our staff members in the tea break area. Our meeting will start again on 10:45. After a short break, I will see you soon.
That's perfect. Just bear with me just one second. Thank you very much. If you could come here.
Okay. Ladies and gentlemen, welcome back to the 2022 China-UK Technology Summit. Here we are on a summit that's full of intelligent ideas and thoughts. And now it's time for our panel discussion to kick off. First panel, we will hear some amazing insights and discussion around the topic of advanced technology for sustainable development. Let's welcome Professor Dong Hongbiao, Dr. Jeremy Woods, Dr. Andrew Wolstenholme, and Dr. Meng Jing. Please give them a round of applause. And also, I would love to introduce you our moderator of this first panel, Mr. Zeng Jingkun, who is Bockingham Inderham Fond's PhD Fellow, Director of the Association of British Chinese Life Science Society. Let's also give him a round of applause.
Yeah, thank you, Serena, for the kind introductions. So welcome to the first panel, Advanced Technology for Sustainable Development. So my name is Jingkun Zeng. A little bit introduction about myself. So I'm a PhD candidate at the Francis Crick Institute, and my research topic is on the cell cycle in cancer. So I'm also a co-founder of SPAX, one of the organizing institutions for this summit. So first of all, I'd like to have a brief introduction of our four amazing panelists here. So from my right to the left, we have Mr. Andrew Wolstenholme, OBE, Fellow of the Royal Academy of Engineering, Fellow of the Institution of Civil Engineers, Chief Executive at Crossrail, Group Director at Lana Rook. And then we have Dr. Jeremy Woods, Associate Professor of Sustainability at Imperial College London, Director of the Imperial College Center for Environmental Policy. And then we have Dr. Meng Jing, Associate Professor of Bartlett School of Sustainable Building at University College London, Research Fellow of Center for Environment, Energy, and Nature Management at University of Cambridge. We also have a panelist joining us online, Professor Dong Hongbiao, Professor in Material Engineering at University of Leicester, Fellow of the Royal Academy of Engineering, Vice President and Secretary General of Association of British Chinese Professors. So we have heard from Mr. Wolstenholme and Dr. Woods from the introductory talks. Maybe we can give Dr. Meng Jing and Professor Dong Hongbiao an opportunity to introduce themselves. Maybe Dr. Meng Jing, would you like to start?
Yeah. Good morning, everyone. Yeah, I'm very pleased to be invited to attend the conference today. I'm Jing Meng from University College London. I'm an associate professor in climate change economics. My research interest is about carbon emission inventories and also climate change policy, technology innovation, and also the co-benefits of climate change mitigation.
So Professor Dong, can you hear us? Okay.
Yes.
Okay.
Thank you very much.
Thank you.
And, hello, everyone, and hello, all the fellow panel members. My great pleasure to have this opportunity to meet you online. As briefly introduced, I'm Professor of Materials Engineering at the University of Leicester and also Fellow of the Royal Academy of Engineering. Currently, I'm Director of UTSR CCDT in Innovation Processing. So my area is in the area of metal and alloys, technology whether into solidification and process packaging, and specification, custom welding, and additive manufacturing of metals. That's all.
Thank you. So I have some seed questions prepared for each of you, but this is a discussion. So if any of you want to follow up like a topic, just feel free to comment and give a go. First, I would like to start with a very broad question. So what does sustainability mean for each of you in your field and maybe as an individual? Who would like to start? Maybe Mr. Wolstenholme?
Well, look, it's a very broad question, isn't it? I mean, in my introduction, I said that a smart city probably balances the needs, and the wants are very different. You know, what do you want as opposed to what you need versus the resources that's available to do that. And I think that this isn't a simple trade-off. This is an opportunity we have to understand the delicate balance of the resources that we have in this world. The ability to understand across the complete globe how we can share those and the technologies that are going to make them more available. So sustainability for me is creating cities, urban areas, societies that balance their needs and their wants with the available resources. And they have to do that by sharing ideals and by sharing objectives, by sharing values, by sharing different systems in common environments, and using technology to help manage the interfaces across those boundaries. So imagine that we are here in 100 years' time having this discussion. You know, what is it that we've done when we run out of oil, when we run out of coal, when we run out of digging primary core resources? What is it that we've done? We've done all of those things about sharing, about introducing technologies, and I think you know, being part of the older generation, being a bit pessimistic about what's out there, as we heard in those introductions, I'm actually very optimistic that we're going to find solutions. But a lot of those solutions is going to be about sharing the values and the objectives around the world, as well as deploying the core values. I think it is very possible. I think it's very exciting. And a lot of the solution, incidentally, sits in this room and others like it around the world.
Thank you. Dr. Woos?
I very much like that perspective. If I think back about our discussions around sustainability, there's a clear danger at the moment, I think, where one specific issue becomes synonymous with sustainability, and at the moment it's not just climate, but it's carbon seems to be the issue that has become sustainability in many aspects. And I think that's really quite dangerous. And I say that for a number of reasons. As Andrew has just said, sustainability is about finding a balanced perspective about how us as humans, how societally, how we use the resources, but don't abuse those resources that we have available. But I think that the other aspect of sustainability that's often forgotten, that emerged from the Brundtland definition of sustainability, which is what the United Nations uses for sustainability, is this concept of intergenerality. So the need to understand what future generations will want, what's possible for future generations, and to direct society in that way, without over-exploiting the resources and without over-exploiting our capabilities to manage those resources through time. And I think climate change is a fantastic, well, in a very negative way, a fantastic exemplar of that, because whilst we acknowledge all of the uncertainties associated with real climate science and the understanding of climate science, we do have a timeline now in place that we have to think about that. And that forces us to think not just about the next 5 years, so moving away from a business and political cycle through into the decadal timescales, into the centuries. And that's absolutely critical if we're going to understand what sustainability is and how to use sustainability to guide societal development.
Yeah, I think it's a broad but very fundamental question, because I think for sustainability, we should consider how to use the limited resources we have, or the Earth itself has very limited capacity to maybe absorb the greenhouse gas emission, because I think for the climate change itself is carbon emissions generated increase much more rapidly than the carbon sink. Because my research focuses on not only climate change, but also air pollution and other environmental questions, air pollution and also land use change, because we have very limited resources. We should consider how we can reduce our rely on the different types of resources for future development, to decouple the economic development from the environmental impacts. And even for the future energy transition, we should also consider on the trade-off between carbon emission, greenhouse emission, and also other environmental questions, the land use change or the biodiversity. So basically, we should consider on how to reduce environmental impacts on the Earth.
Yes, absolutely. Professor Dong?
Right, okay. Just following what has been discussed, I would like to add from a manufacturing point of view. Right, from manufacturing sector, probably I would think sustainability means probably first decarbonization, and then secondly probably need to be profitable, and thirdly to be agile. Right. This has been actually evident in our recent kind of to meet our recent societal need, for example, the Brexit and also the COVID, and how could manufacturing sector and how that have to build up this agile manufacturing system, which can meet the societal need in time. And then from my manufacturing side, was probably there's three routes we can explore. And the first one is the hydrogen economy, second one electric, and third one is digital.
Thank you for the panelists. Maybe I have to follow up with Professor Dong. I know you are an expert in metals, and you recently was elected as a fellow of the Royal Academy of Engineering this September. Do you have anything that you would like to share with the audience about the recent technologies that you are trying to innovate?
Yeah, my area is metal alloys, and in particular look at how to process them by the casting, welding, or additive manufacturing, this kind of manufacturing route. Research in my laboratory mainly fundamental aspects. We said technology level from 1 to 3 or 4-ish. I do work with industries, for example, TWI and Rolls-Royce and Visco, and many other European manufacturing industries. Probably, if I look back, my reflection would be in these three kind of areas. The first one, you need to build trust and make yourself useful to industry. This trust is so important between academia and the industry. Probably as many of you know, the things we do in laboratory, and then sometimes quite fundamental, and a few of them can lead to real product. But you need to have this kind of trust to let industry to believe in you, to support you. And meanwhile, you can really solve the problems. Right. I worked with TWI for a long time, and then the TWI is technology translation and organization. I think this is quite beneficial for me, rather than directly talk to the industry, and I try to benefit from this kind of a technology translation organization that technology values level from 4 to 6, and which saves us a lot of time. Right. So try to look into how to make the journey as smooth as possible, and win support from your colleagues and also your collaborators. And recently, I've been involved in this kind of University UK discussion for international technological collaboration. And under current situation, I would think also we need to look into legal and due diligence check for anything we do in international collaboration, right? And also need to be aware, and then we're talking about technology transfer. Technology transfer is quite complex. We probably wouldn't have one model or one method can fit all of us. So it's a negotiation process. Learn to negotiate and learn to take things forward, right? And thirdly, I would say try to make yourself to be viewed, be seen from from different sectors, and then also being support, as I said earlier, from your colleagues and your partners. That's all.
Yeah, thanks. It's really exciting to hear about all the new technologies and innovations. But metals is just one of the fields that we need to focus on. And as all the panelists said, we need to balance a lot of factors, a lot of disciplines in order to achieve sustainability. So, Mr. Wolstenholme, as an engineer, what do you think are the biggest challenges so far in the construction field that we need to tackle at the moment in order to achieve sustainability?
Well, that's another huge question, isn't it? And I think we learned this morning that I think agriculture or our food sources are the source of perhaps 30% of the challenge we have. We use the figure of around 40%, which is the sort of the demand of the built environments towards the use of carbon and fossil fuels. And I think as an engineer, to actually understand the data, to understand the problem much more, helps you begin to unpack where you need to go forward. And I always sort of split this 40% that is the built environment into three areas. It's the materials we use, including steel, and from an engineering point of view, concrete, and of course steel and concrete goes together. And that's a major use at the moment of carbon. And that's about a third of the 40%. The other third is in-use operation. And actually there's about a third around how we build and how we design things. And it's really interesting that even if you didn't take any cement out of concrete or steel out of concrete, you can significantly reduce the carbon footprint that actually the built environment has by understanding how we design things. I was speaking to someone just before we came in here who and forgive me, the name escapes me, monitoring infrastructure projects, putting sensors on buildings and infrastructures and understanding how they are operating. And I'll give you two very simple examples. You know, digital bridges that Lang O'Rourke, who I work for, builds. We build them in factories. We erect them in days and weeks, and then we monitor them. And a great colleague of mine, Professor Robert Mayer from Cambridge, was at an international conference the other day where the satellites monitoring this bridge recorded the fact that only 12% of the strength of that bridge had actually been mobilized over the first 2 years of its use. So where was the 88% of strength that we put in that piece of infrastructure that wasn't being used? Why did we lock in 80% of the carbon in that structure? So my first challenge is, how do we design these things? What specifications are we using? Why are we using old codes that ask us to behave in a certain way? And why have we got caught up in this? You know, the insurers, the investors, the consultants are all locked into using old codes. So the first thing is we must design a new pitch, design buildings in a different way. Secondly, yes, we must attack the materials. Why do we have to use energy-rich materials, and can we use substitutes? So there's two things there: design differently and use different materials, or engineer those materials. And how do we then use this in operation? You know, Crossrail was designed for 120 years. I can tell you the tunnels will be there in 250 years' time. Buildings, we normally put a life of maybe 50, 60 years. If we doubled the life and we reuse the materials, then you can significantly alter the algorithm around which we record how much carbon is looked in. So there's a huge amount that engineers and scientists and policymakers and owners and operators and the banks who fund them and the consultants who design them and that connected network of people, if they decided to change the way they looked at the built environment, then we could substantially change the amount of carbon that we lock in. I totally agree. This isn't all about carbon, because there's been a fantastic coming together of minds over the last sort of couple of weeks around biodiversity. And I'm quite sure David Attenborough has sat in this place over many, many occasions to remind ourselves of the balance and the sensitivity of the balance, not only of carbon and of the environment and of greenhouse gases, but also the microsystems and the ecosystems that work around it. But as an engineer, there's a lot we can do to reduce the carbon footprint. And the buildings we're building today are going to be halfway through their life in 2050. And the buildings that we build next week are going to represent how we react and respond from what we know today in the world that we understand that we need for tomorrow.
Yeah, thank you for the insightful.
Can I just follow up on that?
No
actually, just in one interesting aspect that I heard about just yesterday, and that's that marine biodiversity, aquatic biodiversity, particularly riverine aquatic biodiversity, is very heavily affected and is actually acutely sensitive to proximity, downstream proximity to urban environments. And previously, we'd always thought that it's diffuse pollution from agriculture and a combination of that with sewage overflows and things like that. This is a UK-specific case. And it's quite a surprise to now hear that downstream environments are actually sensitive, very sensitive to upstream impacts from urban centres, including things like runoff from roads. So the pollutants that come off the roads coming down, filtering into the waterways, you know, the Beckton sewage plant, for example, the way that we treat sewage as a whole. So really interesting and important interactions around the choices that are made when we when we develop the built environment, and then the emergent impacts on the broader natural environment.
Interesting. I guess everything is interlinked. If you go wrong in one aspect, it could lead to like a negative feedback loop, and hopefully that doesn't happen. And also, as far as I know, you have done some research in public health. And also, as you mentioned, that 30% of global carbon emissions is linked to the food system. So what do you think as an individual that we can do to contribute to sustainability, maybe in terms of diet change or lifestyle changes?
Did you want to say something on that, or I don't want to put you on the spot.
Yes, I think we need for the food system, we need both the technology or the actions from both production side and the consumption side. For the production side, because most of the current research, they focus on the carbon emissions within the farm only, but actually the production, the supply chain also generate about 30% of the carbon emissions, and not only carbon, but also all greenhouse gas emissions is from the production side. For the consumption side, the demand side behaviors, I think the change in dietary is definitely a good opportunity to contribute to the mitigation.
Yeah, thanks, Dr. Mo. Maybe to follow up with you, you're an expert in carbon neutrality. Do you think what kind of technologies or what kind of challenges that we should prioritize in order to achieve carbon neutrality?
It's carbon neutrality in general system.
In general, or any challenges that you want to comment on.
Yeah, I think for the technologies, because even we need many technology innovations in different sectors, the energy sector and also the building sectors, transportation sectors. But for most of the sectors, they are also consumers of the energy. I think the energy system should lead the transition, the carbon neutrality. So my current research focuses on many technologies in energy system. We focus on the technology innovation process from the very initial stage to the development stage, because they can scale the deployment and also maybe the stable stage. For many of the technologies, maybe solar PV and wind, they are in the second stage because they have increased in the past few years at a 30 to 40 growth rate in the past few years. And the cost, if we don't include the storage cost, the cost of solar PV and wind is very close to fossil fuel. But for many more technologies, maybe we have to rely on in the future, or we have to rely on to decarbonize the and other industrial sectors, carbon capture and storage, and also hydrogen. The costs are still much higher than fossil fuel. So I think the first question is how can we maybe get the breakthrough technology for our future decarbonization? But I think another most important question is how we can reduce the new technology to make it more easy to be adopted by most of the companies. I think the costs should be another challenge for us.
Professor Dong, what do you think it should be? What do you think should be a future direction of research in the metals field?
Right. Thank you. I'll still probably start with an example, and then in year 2022, the world produced about 1.67 billion tons of steel, consuming 1.5 billion tons of carbon equivalent of energy, and yielding about 4 billion tons of CO2. So which accounts approximately 6.7% of total world CO2 emission. So this decarbonization or carbon neutral is important in the steel sector to meet the societal need. The low carbon manufacture of iron steel has therefore become a crucial role to play in reducing global CO2 emission. In this metal sector, we have actually built up a roadmap towards this carbon decarbonization and carbon neutral manufacturing. Right? We look into 3 routes: look into hydrogen, probably including generation, transportation, and storage, and application in iron making. We have technology available now. We call it hydrogen direct reduction to make iron. But currently, this process is not profitable. So legislation or new policy may be required to enable this technology could be adopted by the industry, and then meanwhile they can make profit. Secondly, we look into electric side. This would be more like towards this from carbon-based to electric-based steel making, such as electric arc furnaces. Again, technology has been there for 20 years, but the UK metal industry was reluctant to use it because of high price for electricity. We cannot compare the price in the mainland Europe, and our electricity price is about doubled or even tripled than the price in the main Europe. Third way is digital. Digital is an enabler. Digital will enable this carbon and electric development in steel sector or metal sector, and to reduce the real cost, reduce the CO2 consumption. That's all from me.
Yep, thank you. Anybody want to comment on this?
I'd love to, because the issue of cost has come in, and carbon neutrality. I'm really curious about terminology, so carbon neutrality versus net zero. And in my mind, a lot of that comes down to the timing of the impacts of emissions. And by saying that, I think that that's really around our ability to adequately reflect what we used to call externalities of production and development into the costs, the current costs of future development. So I think here, when we're discussing activities that will affect, for example, greenhouse gas emissions through time, perhaps over quite long periods of time, questions of the social cost of damage start to come in. How do you account for the damage associated with those emissions through time? Real questions around discounting. Can you discount those costs in the future? How do you integrate those activities so that you come up with a valuation system, an economic valuation system that actually reflects some of those societal questions, the societal aspirations that we have. And I'd be really curious about, for example, when you think about the costings for the energy system, how do you cost current and future greenhouse gas emissions? How do you think about that in terms of those learning curves and implementation of technologies?
Yes, for the current learning curve, we when we designed the technology innovation process, we didn't include the current greenhouse gas emission and future greenhouse gas emission. Yeah, I think it's a very important question because the current greenhouse gas emission maybe generated in 2020 will contribute to the global warming in the next 30 or 50 years than the carbon emission generated in 2050. But for the, I think, do you know any models have included this cost?
Well, yes, it's interesting that, for example, the insurance industry, I'm sure you've come across this question, the insurance industry is now looking very hard at how do you avoid discounting future damage costs when you're trying to do this kind of accounting. And it's so if I think about your point about, you know, we're building a bridge, it's going to be here in 200 years' time, the immediate response is, okay, so it's got X amount of greenhouse gas emissions associated with it. If it's going to last 50 years, we divide those greenhouse gas emissions by 50. If it's going to be 100 years, you divide them by 100. Actually, that's the wrong response when you see the need to try to maintain peak temperatures, peak global temperatures at below 1.5 degrees C. I think we discussed that. Personally, I don't think that target is now at all feasible. But the 2 degrees C target is feasible, or potentially feasible. And so the question is, if we build a whole load of infrastructure now that we design to last a long time, but it causes an increase in greenhouse gas emissions, particularly carbon dioxide, in the next decade or the next 2 decades, and therefore we breach that ceiling in cumulative emissions earlier than we would otherwise done, or we need to do to keep to the 2 degrees C target, are we doing the right accounting there? And so there's some really very serious financing questions that need to be answered when we come to that.
Can I just add something, because the title is Advanced Technology for Sustainable Development. And I agree with everything there. You know, if you have to build a bridge, we'll build the bridge with half the materials you need and make it last twice as long. That seems to be the right thing, even though it doesn't solve maybe some of the issues. But if I come down, this is very sort of macro. If I come down to the sort of micro and look at the and forgive me for talking about the organization that I work for, but, you know, trying to convert the act of construction, building the built environment, into a new way of doing things. We build all the components of buildings or infrastructures in factories. We do it with a fraction of the number of people that you need if you were to take that over outside into manual operation. It means we can actually create cement-based products with much less cement, because you can allow them to cure over longer in a factory. Why am I saying this? Because when you then take these societies, I think that last element of my CV there, health partners. You know, why is health partners there? Why am I the chair of a health company, as well as being fascinated by sustainability and the construction of built assets? Because we haven't spoken too much about the people in all this. And actually, you know, we want to create a sustainable world for the people and for all the other living beings that live on this planet. And therefore, our health and our well-being is pretty important around this. So why do we manufacture things? Because actually, if you go and walk on one of our sites in 2030, it'll be equally men and it'll be equally female. There won't be the manual tasks. There won't be the residual risks that we lay on people at the moment around the injuries that you pick up. You know, I'm not proud of the fact that actually a disproportionate number of people who commit suicide in this world are people who work in the sector that I represent. And so the health and the well-being of the society that we want to produce is equally as important as the what and the how we do it. And therefore, I think to take things into less manual, into more manufacturing, to be able to, as I said, to digitalize those, to feed them into manufacturing, and to allow them to be smart through their asset life is all part of, I think, using advanced technology for sustainable development. And I'm absolutely fascinated and I'm passionate about moving the dial as to how, again, people in this room can think through much better than we are able, forgive me, talk about myself, to think about what the next generation wants, what the inclusion and well-being is of the next generation, and how the outcome of using technology for sustainable development also lands on a society of people who are happy, wealthy, and wise.
Yep. Yes.
Okay, thank you. So if we consider the social cost of carbon, I think you mentioned that we should discount the future carbon emission into the current cost. But I think another question is how, because previous studies or research say we use only uniform social cost of carbon. But now I think the most recent research want to identify the different cost of carbon, social cost of carbon across regions. And from the financial perspective, I know some financial agency and also some bank, they want to calculate their own social cost of carbon because their portfolio of investment are very different. They focus on different types of projects. So their own social costs of carbon are very different.
That's so important. Yeah. Having a different perspective in different places, yeah.
Yeah, I think our time is running out soon, but I have my last question maybe. So especially a lot of developing countries are very vulnerable to climate change and to global warming. So what do you think developed nations should provide to those developing nations in terms of technologies in order to help them to deal with the consequences of climate change and maybe to tackle this issue?
Stunned silence.
Take off or
yeah.
Professor Dong, you want to start?
All right. Yes, I think this is important because CO2 is a global issue, and we cannot solve this problem without developing countries. And then also there are strong actually demand for them to develop, catch up. So I would think probably something we could do in last couple of years' time. I've established 2 centers in India and in South Africa, looking to low carbon manufacturing, essentially by sharing our education system and then also sharing our low carbon technologies, right? And we talk about this technology advancement. Technology plays a significant role. We need to look into societal cost of carbon. I would still believe that technology should play the most important role in this kind of sustainable development. Technology, not only for profit making, also for the, as we discussed earlier, for the health and well-being and the EDI, which is all of them are global things. So for us, we say probably to be more willing to share and to support them. That's all.
Yeah, Dr. Wu.
And I guess all I can do to reflect on exactly that question, particularly in the current time and the current perspectives around, for example, developing and developed countries, we tend not to use that because the boundaries are now so blurred in perspectives. But really what I wanted to say is that where I think our role is, say at Imperial College or elsewhere, is to provide enabling options, enabling frameworks where knowledge dissemination, knowledge transfer is at the heart of that. And so, for example, I mentioned the European calculator, and indeed we're involved in something called the global calculator as well. But we're now also supporting the development of 2050 or 2063 climate calculators for Kenya and for Nigeria, and indeed for, again, with a revised version in China. And at the heart of the development of this is not a developed country passing on something to a developing country. It's very much more about enabling frameworks for co-design, co-development, co-implementation of new knowledge, tools, and understanding. So building from, for example, the bottom up, trying to understand and supporting capacity in the countries to understand the questions that they need to understand their local situation, the local environment, the local conditions, and then saying helping to support what capacities do you need in order to be able to build resilient, agile systems to keep them in place in the face of climate change, in the face of biodiversity loss, in the face of changing demands for food and for land use. So it's much more about building systematic stakeholder engagement processes, building systematic knowledge generation processes that then are built back with smart and efficient systems back into policy making.
Yep, fantastic. I think our time is up, so maybe we should wrap this up.
Just one thing. Like, I think
one last comment.
I think there's a common theme here, because I think it's remarkable. If I threw out a sort of a complex issue here, most of the solution would be in this room already. The difficulty is actually how do you share that, and how do you collaborate in order to make that translate into an outcome. And therefore, I think you can look at all of the COPs that have been, and they've all made some progress. This last one was about paying. How do we fund this? But actually, the greatest gift we can give, I think, to the world for the benefit of humanity is the ability to share more frequently, more often, with less boundaries. We live in a very complicated world, in a very tense time of its evolution. We need to be bigger than that, and we need to transcend many, many boundaries, including the political boundaries, in order to make sure the things that are really important, the things that are really going to make us happy and make us sustainable, are ones that we share with gratitude and with conviction and with meaning. And if we do that, then most of the solutions are out there. I was amazed by the mapping of the DNA. That was a hugely scientific program, but it was mainly a program succeeding in project management and information sharing and collaboration. And actually, most of the solutions are out there, and what we have to be better at is being more generous in sharing and collaborating and making those solutions show up.
Yes, I guess sharing and collaboration are the key to achieve a lot of and to overcome a lot of challenges. So, Dr. Meng, do you have anything to comment?
Yeah, I think for the developing country, if we look at the carbon emissions in the past 10 years, most of the countries with positive growth rate of carbon emissions are emerging countries. So if we want to mitigate carbon emissions in the future, we have to focus on emerging countries because they are still in a growth stage. And also, yeah, big question I want to ask the panel today is, how do you think about the success of loss and damage fund? Because it's very relevant to the developing country. But last year in COP 26, I think we have a big success in the phasing down fossil fuel energy. But this year, we moved the focus from phasing down fossil fuel energy to loss and damage fund. For the developing country, from the mitigation perspective, we should focus on the technology innovation to help them avoid the rapid growth rate of carbon emissions. But in the other hand, they are very, they are exposed to the climate disaster. So they also need the loss and damage fund. So it's like a balance between climate change mitigation and also climate change adaptation. But the success of loss and damage fund may be a distraction of the technology innovation, because we want to mobilize more maybe investment or the fund on technology innovation to help them develop more low carbon technologies. But if we move part of the fund to the adaptation infrastructure, it will reduce the technology, low carbon technology investment. So I think it's the...
Yeah, my apologies, but I think our time is up. It's really great to see the discussion going in this panel. Maybe we should continue when we get off the stage. I think I should pass the stage back to our host, Serena, now. But before that, maybe let's give another round of applause to our amazing panelists.
Thank you, Jin-kun. Thank you to all of our speakers for all of these inspiring and intriguing insights. While I was listening to the panel discussion just now, a very classic Chinese quote from the Book of Rites just came to my mind all of a sudden. And that quote is, 独学而无友，则孤陋而寡闻, which means people who learn alone without communication might very likely be lonely and ignorant. Communication is really the key to keep knowledge alive, and communication is also the key to reach consistent academic innovation. Thank you again for communicating all of these amazing thoughts and ideas with all of us. Let's have another round of applause for all of them. The best time to plant a tree is 20 years ago, while the second best time is right now. This quote indicates that a wise individual would not wait for the opportunities to come to them, but instead seized every opportunity in front of eyes to turn it into bright futures. Now, we will have our second panel discussion around the topic of challenges and opportunities in the China-UK innovation and entrepreneurship ecosystem. Let's welcome to the stage Professor John McDermott, Professor Xiong Yu, Dr. Hu Xiaoran to the stage. And also, our moderator for the second panel, Union Council Chair at Imperial College London and a researcher at the Alan Turing Institute, Ms. Yuki Yuan. Let's give them all a very warm welcome, please.
Hi everyone, my name is Yuki and I'll be the moderator for this panel. So just to introduce myself a bit, I'm currently a fourth year PhD candidate at Imperial College Business School and my research focuses on innovation and entrepreneurship in general. I also do research on digital twins at the Alan Turing Institute and work as a Union Council Chair at Imperial. So for this panel, we have three distinguished guests joining us today, and from my right to left, we have Professor John McDermott and Professor Xiong Yu and Dr. Hu Xiaoran. I will just introduce our panelists a bit. So Professor Xiong Yu, he's a chair professor at Surrey Business School, associate vice president at University of Surrey. He's also the fellow of Institute for Sustainability Leadership at the University of Cambridge. And Professor Xiong is a director of more than 10 companies and chairs the advisory board of all-party parliamentary Metaverse and Web3 Group. He has led investments of more than 35 million pounds in more than 50 companies. And next we have Dr. Hu Xiaoran. Dr. Hu is an assistant professor of management at the LSE Department of Management. His research includes innovation, leadership, cultural differences, and has been published on organizational science. He is also one of the first initiators of the industrial innovation cluster concept. Welcome, Dr. Hu. We originally had Ms. Lu Yingni joining us. Unfortunately, she has to deal with a family emergency at the moment. So we have Professor John McDermott, who is fellow of the Royal Academy of Engineering and also OBE, and he has kindly agreed to join us. Professor, may I ask you to introduce yourself a few more sentences to our audiences?
Yes, thank you very much. So I've worked on safety of complex computer-controlled systems now for approaching 40 years. I currently run a large program around safety and assurance of autonomous systems and robotics funded by the Lloyd's Register Foundation. Talking about innovation, I've been a director of 5 small companies, mainly spin-outs, 2 of which have got to a trade sale, which is a much better average than people normally achieve. So hopefully I can say something about that as well.
Thank you, Professor. So the theme for this panel is challenges and opportunities in the China-UK innovation and entrepreneurial ecosystem. So this is a very timely topic as entrepreneurial businesses play a distinctive role in strengthening economic resilience during COVID and also in seeding the first seeds of recovery. It is also a fitting topic to be discussed at Imperial as we do enjoy a reputation for facilitating innovation and entrepreneurship. So our first question is for Professor Xiong. So as a scholar who pays close attention to frontier technologies, What do you think are some of the current challenges facing our society in developing novel innovation, and how should the younger generation of entrepreneurs rise to these challenges?
Thank you for your question. So to answer this question, I may go back to some of my background, because actually my background is quite complicated, because actually I'm trained as a computer scientist, and I'm still a visiting professor. I got to say, John, also from University of York. I was working there, and I'm still a visiting professor in the computer science department of University of York. But after 10 years of programming, then I realized that the technology developing so fast, and I'm not a very hardworking guy, so I think I should move to business school, you know. So because business school still applies theories that 40 years ago. We still teach just in time, we still teach inventory management. But anyway, but now I realize that technology is developing even more faster than before. For example, I would say that this year, 2022, the biggest thing of technology may not be all in the world, may not be Facebook's Meta, or may not be Ukraine war or COVID. I think the thing that may change the next decade would be the new version of OpenAI. So that's something will create a fundamental change to the society. The digital technology create, all the top 10 companies in the world. They may not be some specific area of sectors, right? So most of them still in digital technology sector. So OpenAI provide even more solutions to enable human to interact with AI, and everybody lower the barrier of AI. So this opportunity, straight away this year, I created 3 companies using OpenAI already by working with a venture capital fund and a technologist. So even early on, I got a call from one of my company called Illume Research. It's listed on Forbes. So I'm a co-founder. So we are creating a new company based on this company. We are going to train 2 million students based on OpenAI. And we can generate a keyword and to help the student with dissertation outline, and also with even write up an essay. But this definitely will cause a problem. This is what I'm warning my team, that we don't cross the line. But that's something you should have a look at. Yeah. So basically, to summarize, there is a huge opportunity from this year. And next year, I already think there may be thousands of companies come from this particular sector. If students from top universities like Imperial, UCL, yeah, I also want to say that my university also ranked #1 in AI as far as a university claim, right? We have the largest AI center in the UK, and also have the highest citation professor, Professor Joseph Kittner. But we all move to open AI sector. Yeah.
Thank you, Professor, for sharing this. My supervisor and I have actually also had a discussion on this, that we can no longer give students assignments as in general descriptive essays, because the AI does a much better job, and we cannot tell the difference. So thank you so much. And our next question is for Dr. Hu. So Dr. Hu, you participated in proposing the idea of industrial innovation clusters in China. Could you please explain to us what the idea is and what implication it has for innovations in China?
Sure. Thank you, Yuki. I think just like Professor Xiong, I'm also not a very hardworking guy either, so I just decided to start out business school, not even trying engineering, all that kind of stuff. Let's start by addressing an elephant in the room. Now, despite huge economic success over the past few decades, to many people, China is not considered to be, let's say, the most innovative countries in the world for various reasons. And there seems to be an implicit assumption that for you to be creative, innovative, there's something about the Western culture characterized by individualism that plays a role, right? The Chinese collectivist culture may have played a stifling or surprising role for innovation. Now, I wanted to question that assumption. So that's the background of all this project, that actually the innovation requires a huge scale amount of cooperations, collaborations, and conversations and coordinations. And that's something actually China is specially positioned to achieve in this new era. And if we can come up with a system that can engage different companies, different stakeholders, and different players to engage in large-scale collaboration to come up with innovative ideas, that we will be able to achieve large-scale innovations in an industry scale. So that is something we called a system that we refer to as the industrial innovation clusters, which essentially is the idea of bringing together different small-scale, medium-sized enterprises and from different industries, bringing them together, providing support for them, asking them, letting them to engage in collaborations, and coming up with innovations that is not at individual level or at the organization level, but rather at the industry level. Now, up until this point, most of the innovations and creativity we've observed in the human society happens at individual and organizational level. And it corresponds with the Western narrative that it is some heroes, innovators, or big entrepreneurs coming up with groundbreaking ideas. So think about, for example, Thomas Edison, Steve Jobs, or big companies such as Apple or Google. Now, that narrative, I can see several issues with it. Number one, it is highly unreliable and unpredictable. If you're relying on a randomized process to rely upon individual creativity, it is hard to predict where, when, and how this innovation can happen. Number two, the product or outcome of innovation coming from that system is a private good for a very long period of time. It may not be equally shared by the society or by different companies, and that lose the potential to tap into the overall potential for innovations to benefit the society. I think the other one is, it is an increasingly specialized world. Not one individual can on his or her own, develop ideas or innovations that are disruptive. We need collaborations. So speaking of which, with the industrial innovation clusters, we're able to creating a system integrating different industries into one conglomerate and providing support at the government level, giving them very good innovation resources, letting them have a conversation with each other, pulling the resources together so they can share the resources and work on this grand level industry innovation together, aims at changing the innovation, changing the industry, but not coming up with specific products or improving existing designs. So that's the idea. That's the theory. Now, in practice, we've been working with local governments in Suzhou, in Jiangsu province, arguably the global hub for manufacturing and industries. It has a very good basis for industry. We help the government integrating 16 different industries into 4 integrated industrial innovation clusters. And over the past year, we've seen huge increase in the amount of resource in terms of the establishment of national labs and also an increasing level of foreign investment in the background of concerns about environment investment leaving or relocating in China. So I think if we can, obviously this is an idea that we are experimenting with, but if we can have some success with it, I think it has huge implications for innovations all around China and in the future.
Thank you so much for explaining this to us, Dr. Hu. I think the industrial innovation cluster is indeed a very novel concept and also speaks to the innovation ecosystem literature. Basically, how can we design a system that continuously generates systematic value co-creation and synergies? I have no doubt that this will have great policy implications for innovation in UK and China. And our next question is for Professor McDermott. You are an expert in safety critical systems, safety engineering, and also autonomy and robotics in general. So what do you think are some of the new trends and opportunities for innovation and entrepreneurship in this field?
So in the sort of field of robotics and autonomy, I think the answer is narrow, well-defined fields. You know, a lot of people are working on autonomous road vehicles. I think it's going to prove very, very difficult to bring those to fruition and to make money from them. There are many, many billions that have been spent already without very much success. But I think there are narrower fields where we will be able to make real progress. In York, we've been working with some companies doing agricultural robotics. Actually, in this country, we're short of agricultural workers, but you can now get robots that will pick raspberries and strawberries, but you can make them operate safely in quite well-controlled domains, and it's true in other areas where people are doing very dangerous, dull, repetitive work. So, for example, autonomous air vehicles to go inspect wind turbines rather than having to send people up to look at them to see if they're in appropriate state. So I think the way we will have success is by focusing on those fields where the safety barriers to introduction are not so great. Also, the social problems. One of the problems with autonomous vehicles is we have a lot of non-autonomous vehicles on the road, and actually the integration of autonomy with human driving, I think, is extraordinarily difficult. And I suppose the other thing to say is actually you need to understand the regulatory framework. In all countries, it's different, it's complicated. And if you don't understand that, you won't be able to bring products to market.
Thank you so much. I think this is all really promising and inspiring for students and scholars, especially at Imperial, because we have lots of researchers working in this field as well. And our next question is for Professor Xiong as well. So you chaired the advisory board of the all-party parliamentary Metaverse and Web3 group. And recently, the idea of blockchain, Web3, and Metaverse have been very popular among entrepreneurs and also investors. How do you think one can stand out and be successful in this field?
So I think this is a very special field. Unlike other disciplines, it's always the elder generation to educate the younger generation. But this particular field, it's a younger generation. They move much, much more faster than the elder generation. So that's why my colleague in the university, even the vice chancellor, the pro-vice chancellor, they keep asking me the question to say, why their children doing this, doing that, they cannot understand, right? So that's why I feel there is a need to create more knowledge within the university so that we can catch up with the industry. The gap is like 5 years already between university and the industry. It's an industry-led sector for metaverse. So I created the academy in University of Surrey called the Surrey Academy for Blockchain and Metaverse. So I get £2 million from a venture capital fund to donate it to me. And so we start to mentoring the students, provide the skill, equipment, and bring industry companies to talk to the university. For example, last week I brought in the CEO of Animoca Brands. So actually, maybe not many of you are familiar with the blockchain company. Have you, any of you heard of Animoca Brands? One? Only one, okay. So, but you must know, any of you know OpenSea? Some people say yes, and Axie Infinity, yeah. So the best blockchain game. Basically, Animoca is the investor of all the companies. OpenSea is the largest NFT exchange platform. But anyway, so the CEO is my good friend, Robbie Young. He created a £2 billion fund with Balance, and he brought the fund into the UK, and then I bring into Founders Factory. So, which is, because today we'll talk about the entrepreneur innovation system. So Founders Factory is one innovation space you should look at. It's created by Brent, who is the founder of lastmailist.com. He sold the company for £3 billion, and he created the Founders Factory, just like China's Li Yanhong created a 创新工厂. So it's very similar. So he's working with me on several other funds. So we try to mentoring the students in Metaverse and Web3. So I think that 2 years ago, the investment go to Metaverse, only $1 billion. Last year, it's $100 billion. So this is the speed. This particular sector is growing. And because of the impact of the sector, then I talked to the parliament. I said, we should pay attention to this sector. It's not only blockchain. Metaverse will use blockchain as one of the enabling technology, but will incorporate VR, AR, AI, and everything else. So that in this way, this will fundamentally change the society. And the parliament agreed to co-found the all-party parliament group on Metaverse and Web3 with myself. So I chair this advisory board because I'm not a member of parliament. And but I lead the 20 members of parliament and ministers to develop the policy, white paper, and evidence meetings, what's happening in this sector. So that's why I think that there is a huge opportunity, because all the funding, they approach us, they want, because this sector is not regulated, okay? It's not regulated means that there is opportunity, okay? And you know, so like CZ in Balance become world #1 Chinese richest people in Chinese community. So in 4 years' time, yeah. So this is a sector that will create the largest wealth, but we need the government to regulate it. So that's why I convinced the parliament to create this group. So we're doing more activities, more innovation centers. I create another innovation center on Oxford Street, so where you will have the event tomorrow, dinner, so in my center. But that center will focus on Web3. Apart from this, I do think there are many more opportunities for Metaverse and Web3, but I just want to address one final thing, that why it's fundamentally different from any other technology. Because traditionally, everybody, you want to create any business, you want to start your company, you create entrepreneurship. The first thing you think about who I work with, and who I should be my partner, my shareholder, my supplier, my client. But now, at least you need to, privacy, at least you need to think about which you should register a company. Yeah. But in Web3 and the Metaverse, you don't need to register a company. You issue your own token. So I recently launched a platform called Pixie. So I don't think any of you know Pixie, right? P-I, in Chinese, you can spell it like a Pixie, P-I-X-I-E. But I only launched it 3 months, and you can download it in App Store. 300,000 users already registered, and 35,000 daily active users. So this is quite good, consider any platform. But many people, even the University of Surrey, said, oh, our professor launched the next generation social network. And the university asked me, oh, how much share you take? I said, I don't have any share. All the share is tokenized into crypto. So anyone who contributed to this platform, they will get their share. So that's why I get more than 100,000 users in day 1. Yeah. So because this new model of value creation will shape the world. Yeah, so this is a question I want to ask. For example, ask every one of you. For Facebook, it's worth $3 trillion. But without the 2 billion users, it's worth 0. Okay? Without the 2 billion users keep creating content, it's worth 0. But why Facebook claim majority of the share, the value? So Facebook should be tokenized and give the value back to the users. But Web2 technology cannot support that. Web3 can. So everybody using my platform, okay, so they become shareholder. They click, like, they review post, they can create NFT, interact with people. All this will get token free. Yeah. And it's now listed in KuCoin, the world's 4th largest crypto exchange on KuCoin. However, now it's the 3rd now, because the 2nd one already collapsed. Yeah. So that's another thing I want to tell you. You should be careful of what you do in this unregulated sector, because some centralized platforms, they may not be so good, right? So they have many wild and very aggressive behaviors, so you need to pay attention to that. But I think the purpose for blockchain is to decentralize, not centralized. So in future, I believe that you should focus more on the decentralized crypto exchange. So nobody can act like a dictatorship, you know. But anyway, so that's all from my part. Yeah.
Thank you, Professor Shen. Yeah, I guess the round of applause is that Imperial has been quite active in the Web3 landscape. We do have lots of collaborative projects on AI, AR, VR with the Royal College of Arts, and some of the works are actually presented at the second floor with the Innovation Design exhibition. And yeah, the next question I will ask Dr. Hu, from the perspective of a management scholar, what cultural values do you think encourage innovation in organizations?
Yeah, sure. Thank you very much. So I think Professor Xiong just got a very amazing and wonderful speech about the innovation from a micro perspective. So I'm an organizational psychologist. I would like to try to address things from a micro, a more low-level kind of perspectives. So I don't think there's one model-fits-all approach when it comes to promoting innovation in organizations, but there are common features. And that's based on empirical research and experiences. So I think you can think about this from different angles. So a culture that focuses on behavior might be the first one to consider. Now, in this case, if we can promote a culture that values experimentation and tolerance for failure, I think it is very useful and conducive for innovation. So think about it. Innovation and creativity comes with lots of uncertainties and lots of risks involved. And nobody has an answer for every single question in this world. So it is important to cultivate this climate of experimenting and try and error, trying different ideas, and not fearing of being judged or evaluated. Now, you can only learn from those mistakes or errors you made. And that's how you learn and how you innovate and keep improving and coming up with something that's revolutionary and novel and also useful. So the second point I would say is more cognition-based. So I'm not sure if you are familiar with the idea of psychological safety. I think many of you are. This is the idea proposed by Harvard psychologist, Harvard professor Amy Edmondson, which talks about how organizational members have a shared belief that it is safe to take interpersonal risks within organizations. It's safe for them to express what comes into their minds and just engage in voice of dissenting opinions. Don't be censored by the superior's opinions. Right? So I think if you can have an environment that is characterized by a high level of psychological safety, people feel much more comfortable to express even like random or ideas that may seem a bit stupid at the first, but by having conversations with each other, you improve them all together, and that gradually becomes more and more implementable and more influential. So if you can cultivate a sense of psychological safety, that's also beneficial for innovation in organizations. Now, I wanted to come to the third point, which is more emotion-based, because cognition behavior is interesting, but emotion is what feels personal to most of us. Now, and this is my own research. I collaborated with professors at Wharton School in the University of Pennsylvania and University of Maryland, where we look at the link between emotion climate and creativity and innovations in organizations. What happens is that we sense emotions carries strong and so heightened social informations that is helpful for reinforcing each other in coming up with ideas. So in a team setting, if we can develop what we refer to as authentic affect climates, which encompasses expressing their authentic, true emotions to other people, don't fake it, just express what you truly feel. Regardless whether it's positive or negative, it can help with innovations. So if it's positive, it encourages people to keep sharing ideas, building upon each other's ideas. Even if it is negative, then you constantly know the ideas may not be the best, and you can tweak it and constantly kind of changing and shifting sort of the conversations, and that helps build a collective atmosphere for information elaborations that helps with creativity and innovations ultimately. So that would be the three angles I'd like to offer, and I try to keep it brief. Thanks.
Okay, thank you. It's really interesting because Professor McDermott just talked about physical safety, and then you brings up like the sense of safety in organizations are also very important for innovation. For the sake of time management, we'll just ask one final question for Professor McDermott. So what do you think are some of the challenges or opportunities facing startups in UK now? And do you think it's a good timing for students to start their own business?
I don't think there's ever a particularly good time or a particularly bad time. It's actually having the right ideas that match the market. Perhaps I could say some things, though, from my experience about what's actually helped people at companies I've been involved in and have seen that have been successful spinning out from universities. I mean, first, I think the most important thing is that normally what's coming from the university is the innovation, the ideas, and the researchers want to take those ideas to the market. So the first thing is to be very brave and to say to appoint somebody else as the CEO. Usually the people who have the technical skills don't have the skills to run a business, and they also need to spend their time working on the technology. So I think they need to do that. The second is you need to understand the market dynamics. I mean, in your case, it sounds like the time to value is a day. In a company like Rapiter that sells software engineering tools into aerospace, it's typically a year and a half from first contact to get a sale. So you need to understand those dynamics. You need a very good accountant, because in that situation, actually what can kill you is cash flow. And of sort of 2 of the 5 companies I've been involved in, actually the thing that was their downfall was actually cash flow. They had an order book, but couldn't actually bring in enough money to get to the point of delivering against that order book. So I think there's a lot of things, but actually I don't think it's particularly good or bad time. It's actually understanding your market well enough, what takes you there, and getting the right skills in, which the academics don't normally have. Okay.
Great, fantastic. So tons of thanks to our amazing panelists today who have kindly shared their thoughts and insights. And indeed, as they mentioned, our societies are facing unprecedented challenges, but they may well also be opportunities to enable entrepreneurs and innovators to be baptized by fire and bounce back stronger. So I hope our audiences enjoy this conversation as much as I did, and I believe we all have something to take away from this. Let's give our panelists a round of warm applause, and I will now pass the stage back to our host, Serena. Thank you.
Thank you. Thank you for all of this amazing insights. I don't know if you have, but I've completely drowned into some of the ideas that our speakers have brought up. I believe these words have not only inspired me, but also inspired so many others who want to have a say in today and future's entrepreneurial world. And I believe after what we learned today, we can cultivate much more creativity and capability to work towards a brighter future. The summit is full of great thoughts and in-depth sharing. Via the exchange of ideas, I believe we have all gained some great ideas in one way or the other. A huge thank to all of the speakers, and also a huge thank to all of our collaborators. I hope you have a great time listening to today's discussion at the main forum of 2022 China-UK Technology Summit. Thank you all so much for coming. Hopefully, we will see you next year. And before you leave, we would love to invite all of you up on stage, and we will all take a picture together.